Hi, I'm Chris Moore with HVAC Pro Blog, and welcome back where we are presenting part 3 of a 3-part series on ACA Manual ZR's Zoning System Diagnostics. This week we're going to wrap this up by discussing damper retrofit and evaluation, a little bit of fan law number 2, and bypass damper issues. Keep in mind, this was a recorded webinar provided to my Patreon members 1 year ago. Without further ado, here's part 3 of Zoning System Diagnostics. When you retrofit a damper, all right, you can't just willy-nilly throw one in the duct system, all right? It's really, really important before you do that. You need to know the blower performance and how it's going to change, okay? You need to measure the airflow across the heat exchanger. So in the actual operating season, like as it's operating, measure the volume of air. There's many ways to do it. I'll show you one in a second, okay? But there's most people either use a true flow plate or static pressure or total velocity probe, right? With inches of water column and a blower chart. Some people will use a pitot tube. Others will use a duct blaster. When they test the duct work, they can actually do duct blaster pressure matching and see what is actually moving through that duct blaster to fill that duct work. And then other people actually will just measure leakage and then measure the actual output of the air, right, at each register with this, like let's say an Alnor hood, and then they'll know the difference is your total, right? So there's many ways to measure it. The key is that you measure it, okay? I've actually, very simply, there's an equation that you can use to measure sensible temperature in the return and the supply. You can do the math and know volume of air pretty easily if you know the output of the furnace in BTUs, right? So there's many ways to do this with fossil fuel. Obviously, with a heat pump, there are some other ways to do it. But basically, you need to know the full volume of air before, because if you don't have enough, putting a duct system in, putting a zoning system in is only going to probably make it worse, right? And then you actually need to measure how much air is coming back from each zone and how much is being supplied to each zone. So if you have multiple returns, you should be measuring the volume of air at each return as well. And static pressure goes a long way here in knowing that you have a balanced system when it comes to sizing and that it can handle additional ductwork or a zoning system, all right? So one method, I personally don't recommend this. I've actually done this many times with a hot wire anemometer or a mini vane anemometer, is doing a duct traverse, right? And you can measure the feet per minute and convert that to CFM, cubic feet per minute, by getting an average of all of these measurement locations. It's just really important that you measure it. Use any method that you're comfortable with. Unfortunately, this particular one is not very repeatable. Every time I took this measurement, I got a different number. So keep that in mind. Try to use a repeatable method, so that way you can make sure that the airflow you measured is correct, that you just didn't make a mistake and you turn that mini vane slightly and that's why you got lower volume of air, right? Next piece that you need to do is actually evaluate the duct system first. So you need to have a complete drawing of the duct system. This is one that's pretty crude on the right hand side here. Can't take credit for that. I found that one online. But we want to indicate the size and actually the measured static pressure of the trunks, okay? Very important, because this is going to help us then find out what the volume of air is going to be or is after we install the zone system, all right? So we also need to record the minimum and maximum CFM that's needed for that furnace, air handler, or whatever it is, right? Because there is a minimum before that coil freezes or that heat exchanger limit goes, right? So very important, you know what the minimum and maximum are. And then we're going to actually record the current situation for blower full load amps and voltage. And then, of course, the total measured airflow we're going to jot down. Then, I know this is a tough one for a lot of you guys, but you need to do a room-by-room load calculation. And this is really important if you have an existing duct system to verify that the ducts are sized correctly for those spaces, because when you retrofit a damper system, it's going to be most likely open-close, and if you don't have the ductwork sized correctly, we're going to really skew the balance of the system, okay? So you need to do a room-by-room load calculation first, fill out the Manual D worksheet or print off the Manual D worksheet off of your software that has the CFM needed for each room, all right? Then you would measure the volume of air in each room, make sure the equipment's clean, it's charged right, it's operating correctly, and then any sort of system deficiencies are addressed first in order to then install retrofit dampers. Now, you can use fan law number 2, right? In order to calculate the volume of air when just a single zone is opened. So it's really easy. If you measure volume of air in the beginning and you know your static pressures when everything was open versus in the trunk when only that one zone is open, right? So if you use this math, it can tell you exactly what you're looking for, what the volume of air going through that one zone is now when the other damper's close, right? So as an example here, let's say we measured 1,327 CFM, right? And in the trunk, we had a 0.3 inches of water column static pressure. Then we added the dampers and closed down all of them except for the smallest zone. This is worst case scenario, right? The static pressure on the main trunk now with that smallest zone open was only 0.12 inches of water column. So if we plug these numbers into the equation here, of course you're going to do static pressure beginning divided by static pressure final first. It's within the parentheses. And then that 1/2 is square root. All right, so keep that in mind. So the square root of that number, and then divide that from your beginning CFM, and that'll tell you how much CFM is actually operating now with that one zone open in that trunk, right? So when we close everything else off, that one zone in this example is getting close to 840 CFM. All right, pretty simple to do. Another example here, and I'm doing this so that way you can see I can just talk you through an example. So hopefully you can walk back if you ever do this in the field. You can listen to this or print off the PDF of this presentation and see this example, right? So you measured in this example 1,400 CFM, and then the supply trunk with everything open had 0.2 inches of water column. Obviously, this is probably just a 2-zone system here, right? And you can see we closed down all but the smallest zone, and then we measured the supply static pressure in the trunk again, and now it was just 0.14. It's less, obviously, right? So we plug in these numbers here. The 1,400 we measured, 0.2 at the beginning, 0.14 with the smallest zone open and everything else closed. We do the math, and it ends up being 1,161 CFM. I have a feeling that wasn't the smallest zone in this example, all right? I think the remainder was probably the smallest zone. All right, so when you're not getting enough volume of air, a lot of times it's probably the set points for your dampers for dump zones or the setup of your bypass damper. And that tends to be the number one thing that's neglected, I think, is large bypass ducts, right? And there's typically 3 configurations that usually have design flaws. The number one thing is a barometric damper, and it's missing a balancing damper with it, right? So there's usually a summer and a winter setting. Like I was talking about before, if you have a bypass style humidifier, the damper on that bypass damper is now going to have a different barometric setting, and you need to change the volume of air, right? So that's one thing. Open close electronic dampers without balancing dampers, right? So if you don't have a balancing damper, if it's full open and you don't balance the system out, you're just gonna get full air, right? So that's another error that I see that's typical around bypass damper systems. And then of course a bypass duct that's just way too large without a damper at all, right? So you're just bypassing all that air, and it's a rat race, and it's do the thermostat satisfy first, or does the system hit limit, or does the coil freeze, right? And you're out there and you're scratching your head wondering why we're not cooling the air. Probably bypass air, right? That's usually the first thing you need to check on a zoning system. So obviously you need to measure and evaluate the system, put the system into worst case bypass airflow, and that's what you're gonna set that barometric damper for, right? So in other words, if you need X amount of volume of air in that example before, and you're measuring static pressure, you know what the static pressure needs to be to hit it, you just gotta adjust that bypass damper to hit that static pressure in the supply of that zone, of the smallest zone, and we're bypassing the rest now, right? That's the easiest way to set one of those up. Obviously, when you do this though, you still need to measure entering air temperatures and make sure you're within limit. You don't wanna have the furnace shut off 2 days from now when it's colder out and it's running longer, right? So you still have to operate within limits. And then obviously, you want to make sure that you're going to be able to control that volume like I was talking about before. And this is really designed using ACCA Manual ZR. There's quite a few worksheets that's in the last appendix. Highly recommend you walk through if you're going to design even just a 2-zone system, particularly if you have a bypass damper. Now there are plenty of zoning systems out there that don't require bypass dampers or won't let you use a bypass damper with these communicating variable position versions. that's great, especially if it's made for that particular manufacturer because it communicates well with their heat pump or furnace, okay? If you're retrofit fitting something and it needs a bypass damper, please walk through the worksheets in Manual ZR, all right? Obviously, after you set the system up, you want to verify, like I talked about in the beginning, that the system's working as designed, all right? There's a lot of systems, when we talk about zoning, that just fall into a state of disrepair because technicians don't test the controls and the dampers. They go out there, they clean the coils, they change the filters, they make sure the blower's operating fine because all the zones are open, and then they leave, all right? You need to test them all in the off and on position, each zone. I know it takes a little bit of time, but it's really important to keep these operating correctly so we don't cause further problems with the system, like zones that shouldn't be shutting off, the system's running, and now we crack a heat exchanger or something, right? So very, very important. You do a complete zone function test. It's really easy, just takes time. So last thing I want to mention here is how important this is to document on startup. So if you have all of these notes, it's going to make your diagnosis down the road, or the technician that works with you, their diagnosis down the road, much easier. So you can see in this example, the homeowner complains that the new system worked fine for a couple years, but now the bedrooms are just not comfortable. So a technician goes out there, and usually they're diagnosing it on the way, right? I bet it's undercharged, or I bet the filter's dirty, or all these things that immediately pop in your head after a few years if you haven't been there, right? But in this example, because they put a zoning system in, they have a record and copies of the original duct static pressure measurements on the startup sheet. So if you have measurements of all of these positions all the way through the system, after you measure a couple of values in external static, it's really easy to identify, do we have a dirty blower wheel, right? Or a dirty filter that might have been insulated over. I've seen that once before. Do you have a dirty coil, right? If you're measuring pressure drop across a coil, it's really easy if you have the same volume of air to know if that thing's getting dirty now. So if you measure, it tells you a lot of things that down the road when you remeasure it, how far off it is from design, right? And that's when you start have to, let's say, cutting into plenums to clean coils, right? You don't want to do that not knowing, because it's time consuming, and if that doesn't fix the problem, probably not getting paid for that labor, okay? So very, very important. Document this stuff. I've actually personally wrote those numbers right on the duct system if you can do it neatly, maybe with stickers, okay? That way the technician that comes back from maintenance every year afterwards can take an easy measurement and then just retape that hole over. It's really simple. So what did you think? Did you like zoning system diagnostics? If you haven't seen the first 2 parts of this 3-part series, be sure to go back to the system design playlist here on YouTube. If you like these videos and you want to get them 1 year in advance, you can subscribe to my Patreon membership page for as little as $8 a month. That provides you access to the last 2 years or 24 written blogs and 12 months worth of videos. That's 1 recorded training every month. Thanks again for joining me this week at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you soon.